So let's start next talk about UEFI Secure Boot implementation in QubesOS, or maybe more about challenges and future steps, how we're planning to do this, or maybe how Marek plans to do this, because that's probably mostly on him and Frederick. So first of all, thanks to Kamil, Marek, and Andrew for reviewing this presentation and giving me some feedback. So I tried mostly. So the goal is to briefly explain what is UEFI Secure Boot and what led to all this like open source software dislike for UEFI Secure Boot. To give you better ground, because I saw a lot of FUD, a lot of weird comments regarding UEFI Secure Boot. There's like massive misunderstanding what it is, and this is part of the presentation to unroll that. On the other side, I have very strong my personal opinion about how it should be used, which is I guess it is not exactly the same as most of the distributions, but I guess like that could be a point of discussion, and yeah. So I will try to justify that the only valid way of UEFI Secure Boot use is what Trammell defined in the Safe Boot project, which is defunct unfortunately, but it is what it is. So how the modern computer boots, just quickly. So typically at the beginning we have some root of trust, or maybe we even don't trust it, but there is beginning of the word, the anchor of whole boot process. It is typically associated with some fuses, like Wessel already mentioned, like Intel Boot Guard, or there is AMD Secure Boot. So it starts in this coprocessor, and then there are phases defined by UEFI specification. Of course, core boot got alternative phases, U-boot got alternative phases, but it's almost the same responsibility. So there is seg phase, PAE phase. I will not go deep in that. There is Dixie phase, BDS, and finally we can jump to the bootloader. So it is the most important part, I guess, here is, and then after bootloader we have OS, and bootloader starting to be optional these days because of the UKI, or maybe we can say like bootloader is built into the system image. But anyway, this is like from our perspective is starting to be one binary. So this first part is typically covered by silicon vendor chain of trust technology, and this part is covered by UEFI Secure Boot. What is important to note here that this connection, this one, is not enabled by default. Even more, I will show on the next slide. The problem is that the chain of trust is not always continuous. So between Dixie and BDS, so BDS is just a Dixie module, but despite the whole infrastructure for verifying BDS is in place, and if Secure Boot is enabled, BDS should be verified. Typically in implementation it is not, because there is assumption that if something coming from flash, it's already trusted. So which maybe is not the best assumption. Of course, if the UEFI Secure Boot is not set, then there is no verification at all. So every component is boot without checking the signatures. Yeah, and of course, this is state for the reference implementation, not the state for, your favorite vendor, BIOS vendor could have different configuration. Okay. So the last thing is that, of course, you have to have full chain of trust. So you have to connect the silicon vendor chain of trust technology with UEFI Secure Boot. So typically it is called independent BIOS vendors or independent firmware vendor chain of trust, because this jump have to be somehow glued. Okay, so I guess this is important. This is a piece of the code which doing the policy check based on the image type which is executed. And on the top you can see that if image is from firmware volume, always execute. So yeah, there is no check. nothing is checked. It's essentially if firmware, if the piece of executable image coming from the firmware volume, it is like immediately executed without any signature checks. Then you can define that option ROMs. If this PCD option ROM image verification policy is defined, then it means firmware will do the signature verification of option ROMs. And Marek, just like let me know that this is very important, because if you pass the GPU into the potentially malicious VM, and this VM will be able to update the option ROM in the option ROM of the GPU, and then after the restart, this GPU will be connected to something else, or even to DOM0, it can compromise the security of whole system. Yeah. But on the other side, we tried in Dasharo to enable that option, and it happened that some GPU vendors do not provide signed option ROMs, and then you essentially ending up without graphics. Yeah. So we have to think what we're doing, and think who's compatible, and yeah. So let's go with the policies. Then we have image from removable media. So if this PCD is defined, then whatever you put on USB or external, like a storage or SD card, will be verified. And then fixed media, those are the media which are connected inside your computer, so like a disk or NVMe or something like that. And default is security violation. Yeah, those are possible other states. So you can have a policy always execute, never execute. You can have allow execute on security violation. So this was, I guess, all this MSI problem that they essentially said that one. So despite it was something wrong with the signature, they executed. The fair execute on security violation. So I'm not sure how this works precisely. Maybe we can talk with Michał after, because like I don't want to give you wrong answer. And query user is just like a pop-up in BIOS, if you can say so, that there is security violation, and just like what I should do. Should I continue or should I stop? Okay. Why I even show you this slide? How is this related to QubesOS? It's not related to QubesOS, but I want you to understand that the correct configuration of UEFI Secure Boot is not enough to protect your platform. There is like assumption from Linux kernel community or from many players in open source security that UEFI Secure Boot, if this will be correctly handled in shim, with SBATs, with all that stuff, we are already good. No, we are not good. We are just like shifting the responsibility to someone else, and this someone else proven many times that they cannot deliver maybe the best quality. So root of trust have to be in place and chain of trust have to work, so UEFI Secure Boot can do its work. So to maybe to be more bold with that statement, UEFI Secure Boot is the chain of trust technology, but the last part, which doing the transition between firmware world and bootloader, hypervisor, operating system world. So it's just the last part of the equation, not the panacea. Okay, something about keys and how keys work in UEFI Secure Boot. Also, I don't want to go too deep with that, but the point is that to understand vulnerabilities, which I will present in next slide, so you understand what really meant the boot hole, the PK fail, all this stuff, because this is also FAT. Like UEFI security is broken. It's not true. It's the broken was configuration and keys and various other stuff. But anyway, so the structure of the keys in UEFI Secure Boot look like that. There is a platform key, so PK, which allows update key exchange key, which is this KEK stuff. And then KEK stuff, key exchange key, allow to update the DB, which is database of allowed signatures, allowed hashes, allowed public keys. DBX is a database which feels denied one. So you put the hash there or the hash of the X508 certificate there, and in that way so UEFI Secure Boot, if sees that, then already say this is security violation if anything is in DBX. DBT and DBR are like more complex databases because DBT is for time verification, because if the certificate expires, then you need that database. But the problem is, of course, you need some genuine source of time, and that's another problem. And let's not go that way. And there is like this recovery database. I don't remember exactly what's the reason for that, but that's maybe not most important for our discussion here. Yeah. So what's really was the problem? Yeah, So everything started with the fact that Microsoft became a holder of the UEFI CA key, and this UEFI CA, where it lands is there is information here in the third bullet point. So Microsoft provides certification to those who will comply, to those OEMs who will comply with given requirements, and those requirements are that their PK key certifies Microsoft key exchange key, and they put just like Microsoft because PK allows to put the KEK into that database. So the OEM who wants to be certified have to put Microsoft KEK and two other certificates into the B, so allowed database. The one is Microsoft PCA, which signs the bootloader. Then the other is UEFI CA, which signs all the other software, like Shim and like any other software that is outside of Microsoft. Yeah, and the problem was with this UEFI CA. So yeah, so the problem started with the fact that Microsoft became a holder of the UEFI CA. And why did this happen? Yeah.
Very quickly, it's also worth noting that Microsoft did not want to do this. They originally wanted the same people that do SSL and web certificates.
Yeah, so
Microsoft lobbied hard for them to do it, and they said, no, we're not getting involved in this firmware stuff.
So that's
Microsoft had to do this for their own plans to work, but they don't like being here.
Yeah, I guess we can place the microphone just so other will listen, but I will repeat that. So Andrew just saying that it's very important to underline that Microsoft didn't want to do, and they really wanted to do things in correct way. And yeah, I heard also that, and I think this is valid story. But the point was that nobody else had at that point infrastructure to hold that. And they already had infrastructure for signing drivers. So that's why it happens, because nobody else from UEFI forum could handle that, and that's it. And there's also the question about the resources and processes. So they had resources and processes in place, and that's how how we land in this weird situation, which led to what I show you on the next slide. Yeah. So I already said everything here. Yes, so PK fail. Like recent stuff, I guess I've been early reporting a lot of they finding this in here and there. So they are reporting a lot of that. But it's essentially this is so stupid mistake. It's like so many vendors were just so lazy that they use it like a default or reference implementation of AMI with some PK generated there in the code. Like AMI left that for simplification of UEFI Secure Boot configuration. And they just didn't generate a new one. They used the one which was shipped with the code. And everyone uses that. And of course it leaked. And now everyone can use this PK to change the KEK or do everything, because PK owns everything in the platform, and that means the secure boot is compromised on those platforms. Then we have UEFI shell considered harmful. Some vendors added the UEFI shell. This is the debug code, and yeah, that's something that gives ability through tool to bypass secure boot. Yeah, so this is something that have to be also. The boot hole. Boot hole is a not one vulnerability, but a lot of vulnerabilities. But but it is not vulnerability in UEFI Secure Boot implementation or mechanism. It's a vulnerability in the code that is executed in chain of trust. So, for example, shim was signed and then shim executed grab, but the grab got multiple vulnerabilities which allow it to bypass this chain and essentially run untrusted firmware, unauthenticated operating system or whatever in the chain of booting process was there. But the problem was that shim didn't have, so Microsoft signed the shim, but shim itself didn't have a mechanism for revocation at that point. So essentially didn't know if the next thing that it's booting is vulnerable or not. So this caused to the situation that it escalated to the one layer upper with the revocation. So it means that whatever Microsoft used to sign the shim is already broken because they have to revoke those, essentially revoke all the shims, yeah, which allow the run of the grab with the vulnerability. Yeah, and that was like whole mess. A lot of people involved and hundreds or thousands of hours lost because of that. And of course, what's the cure here? Let's add more. Let's add more in the same way. But I will tell you on the next slide. So, but it is very interesting. This boot hole is very interesting because suddenly we have Black Lotus and those bootkits, which are related to Microsoft Windows. I just like copied the node from there because I don't know bootloader of Windows, but it's explanation what's happened here. That Windows boot application allow the truncate memory setting to remove blocks of memory containing persistent ranges of serialized data. In that way, it caused the secure boot bypass. But it's essentially the same mechanism which was used in grab. So essentially, the code which was in chain of trust, someone found that you can trick it to bypass. So it didn't preserve chain of trust, and in that way, it started the revocation. And of course, it was the same mess, but in different ecosystem. Yeah, and it looks like sometimes the cure happened to be worse than the disease. And of course, right now we have a situation in which Microsoft trying to maintain security properties of UEFI Secure Boot on the hardware they certify, because of course this damages their brand and that's not good. And then, of course, this generates another requirements, like a lot of requirements, various, because they want to be as strict and really do the things correctly right now. And they tightening this signing policy, which, of course, create a lot of issues in open source ecosystem, because open source ecosystem is very diverse. There are various ways of booting things. There are various things of implementing things, and suddenly everyone have to comply with some very similar rules. But of course, we're not saying these rules are wrong or bad ideas, because many of these rules are probably good one. But essentially, this is like we going this rabbit hole. We continue that. So we have SBAT, the Secure Boot Advanced Targeting. And it's essentially a mechanism for revocation in the shim. So you essentially get the same thing like with DBX, but at the shim level. Yeah. Of course, like it's worked a little bit differently because it has, it's not relying on the certificates, but final result is the same. That the shim will have knowledge what it can run, what it cannot run. Yeah. And of course, then the process of signing shims is very bureaucratic. It's extensive. I know Kamil already sent application on behalf of Qubes, I guess, or try it. I saw the repo prepared for that, and he's attending the calls. So yes, Kamil is on that, and yeah. So there is review repo. For doing that, and every distribution or whoever wants to do that, they have to go through this review process. Yeah, there is like this integration with HSM mandatory, which is of course HSM are very custom, and then you have like this, like everyone have to resolve that their own. Yeah. So my conclusion here is like this: like almost no one attacked the UEFI implementation or mechanism in BIOS itself. They attack either something in the chain further, or they just using misconfiguration. So that means that it's not that implementation is wrong, or like maybe it's wrong because maybe this X508 and then methodology is something wrong with this, or they didn't thought about all possible paths. But on the other side, this can be used in valid way. That's my point. And maybe we will get there that someone will find vulnerabilities there, because maybe those vulnerabilities that we face right now were just simpler. Okay, so let's go to Qubes. So it looks like, just to be clear, those are requirements for being signed by Microsoft, not for secure boot a la safe boot. So not for signing yourself, like cleaning up all the databases and populate it with your stuff, signing the kernel, and so on and so on. That was Trammell goal. And okay, everything seems to maybe it started earlier, but that's the oldest kind of tracking record that I was able to find. In August 2017, Wim Verwoon from Eltan asked the question about like production-related system on the mailing list, and there was like very long discussion. It's like reading that is already interesting experience, but Marek replied like what would be needed and provided some first kind of expectations, and I guess that started. Then there was this 4371 in October 2018. There is also quite interesting discussion there. Then Trammell reported on that issue that he booted QubesOS 4.1 with secure boot enabled leveraging unified Zen EFI. Also sent some patches which were merged, but I guess this was not everything because of the requirements. But initial concerns, I guess, from Marek was that Zen EFI reliability while loading from different from different medium, from different implementation of UEFI, and also how to access the files, the kernel, the initramfs, and so on. But I guess the solution is that to build everything in kind of UKI way. And other concern back then was about complexity of boot parameters and the fact that some boot parameters are maybe not exactly safe and could lead to bypass, if we make this static, then we have problem of any debugging or adjusting the boot process. Marek requested effort for signing boot images in May 2023 in this 8206. Last year we discussed inclusion of the QubesOS CA, but I assume that this is not the path right now. Am I correct? Last year we discussed that that we could in Dasharo include QubesOS CA, and on Dasharo it will just boot without being signed by Microsoft. Yeah, but my question was in the issue. My question was when we will get that, and essentially this is comment open for last 12 months.
Yes, there are other stuff.
Yeah.
That are like higher on the list.
Understood. Yeah. So that's also kind of the thing that there are more important stuff coming. I know that Frederick worked on improving Qubes Builder version 2 to include P sign for signing keys. This is this PR77 if someone is interested. And I tried to kind of take the ISO and try to modify this ISO, try to figure out if there is a way to take the ISO right now and do something with it to essentially boot with secure boot with my own keys on the platform. But Marek's told me that this is just like not good use of my time.
There is a very long object copy command you need to use to put this unified ZEFI binary.
Yeah. So
not nice.
Yeah, I have to speed up a little bit. Yeah, but the current approach is to build unified Zen EFI, and there's already task for that. There are some pull requests flying, and the plan is to provide the pre-built Zen EFI binaries in R43. Maybe the first question would be, is it like this would be default boot method, or this would be alternative boot method, or how this would be?
I'm not sure yet.
Yeah.
We'll see. But
Yeah.
We plan to provide the pre-built binary that is signed with some key, and user can do something with that, like enroll the key to a firmware, or there are some options.
Yeah. Zen. Yeah, so this is from Andrew, mostly, plus some my gathering from discussing with him. So, like these are requirements to be signed by Microsoft, not the requirements for this other scenario, for the Trammel safe boot scenario. But yeah, SBOT support is needed in Zen, not present right now. NX compat. So this is like this bit of if you have executable code in your data section of the binary, and this is something that is required by SBOT to comply with. Then there is kexec leveraged inside Zen. Then there is need for integrity checking and signature checking in this kexec stuff. So yeah, yeah, I tried to discuss with Andy to understand this purgatory stuff. But essentially, the point is that some things have to be built from kexec, have to be built in Zen to move on. There is live patching feature, which have to start checking signatures. There is this stuff with the unsafe command line options. The ABI, the hypercalls ABI for checking all passed pointers. So I guess this is also some additional work which have to be done. There are some debug options like just the GDB stuff. I don't know if this is not already done, but yeah, this was also mentioned as a potential issue. So all these things, it's a lot, have to be.
No, GDB stuff's fine. We deleted it earlier this year.
Oh, okay.
Completely unrelated reasons.
Yeah. So yeah, okay. So anyway, so the last one is done. Yeah.
We deleted it for a speculation safety to fix a speculation bug.
Okay.
That's not what I wrote on the commit in public.
Yeah, yeah. So unsigned code can't make any unaudited read writes, and that's the rule of all those technical jargon here. Yeah, and not everything affects Qubes, but the fact is that the one who will put together this binary have to ensure that the DOM0 will have lockdown mode, just to make sure that it will preserve the security properties. So what we can do right now, we can choose hardware which gives ability to easily bypass things or kind of trust something quick and fast, like HP and Acer BIOS implement ability to trust this binary, or trust this binary for next booting or whatever. Not ideal, but could be implemented, this kind of approach in the shadow. Maybe the question is to the QubesOS team, like what kind of issues you see with that. If this is not good path, or we will get other paths working earlier, then great. We can wait for R43. Marek don't know when there will be release date, so you can just wait and be patient. You can try to compile unified kernel, like Trammel did, and you can disable UEFI Secure Boot, of course. And even if we will do this, it would not be end, because we don't know if we have this system, let's say this HP system or this Acer system, we don't know what capabilities we may have in this system. We don't audit the BIOS, so we don't know where those keys leaked or whatever they have there. There's also UEFI specification on which UEFI implementation can have some issues. There's no easy way to check what UEFI specification you comply to in your firmware. And every implementation may do things a little bit different. So I guess like use open source firmware, because otherwise you don't know what they put there. And how you can verify those three things? You can just try, test, have like extensive validation suite to realize if this is good. Yeah, or trust version compliance. Yeah, and I think that on hackathon I will try something of that, like a Qubes builder and trying this unified image, and that's it from my side. Thank you.
It's good. It's not a question, just comments about building unified kernel image. So I've made some pull requests indeed in Builder v2. It's a matter of adding some an RPC service, but it's mostly building some component that will be able to sign the UK image. So I've recently improved documentation. I think like maybe 1 month ago, 2 months ago. So
yeah,
yes,
I saw that. I tried to analyze that, but
good
didn't.
idea.
Yeah, I see that I already had too much slides. If I would try to add even more technical stuff here, probably will not fit in. But I looked into that. Of course, my main problem, as it was 2 years ago, is Qubes Builder. I'm not essentially like I have Qubes, so I hope that during hackathon maybe you can help me, or
Yeah,
just to start with that. And I would like, my goal would be to run in QEMU the unified kernel and see if with let's say I don't know, do RSA 8K signing, and we will see if this will run.
Yes, exactly. And I've tested on the Threadripper platform also. I was having several issues with that platform, but it worked. So with even with some
Which platform?
Threadripper, AMD Threadripper platform,
okay.
known to have some several issues with E820 mapping, something like that. And I tested this unified build, it worked.
Okay.
Yeah.
Okay.
So
But did it enable secure boot?
I know, not at all. But
Okay.
the payload works. I mean,
Okay.
yeah,
You're saying just
works.
like it's booting. Okay, that's fine. So we will check without signature check in QEMU if this works. If it works, then we will enable secure boot and see what's going on. Hi.
If I understand correctly, the whole chain of trust originates basically in the Intel ME, and that's still proprietary firmware, isn't it? So is there no way around trusting the silicon vendor, or what is your stance on that?
No, I guess you don't have better way right now. Yeah, it's going even in worse direction, because without ME you will not have sleep states, modern sleep states. So it's like I think sooner or later we'll end up in a situation that cleaning up ME will render unfunctional device. So I think this is the case for the most modern laptops that will come, and most modern like hardware like we have like on Meteor Lake based, or maybe it's even Raptor Lake also. So that's the problem. And yeah, but you know, Intel BootGuard from the mechanism side was not bad in that term that really nobody broke the Intel BootGuard by itself. They broke the configuration, the same what I said with the UEFI Secure Boot. So this mechanism was broken. Of course, like if you don't like proprietary implementation, then nothing will justify that. Yeah, but I'm saying on x86 hardware you don't have much choice. That's it. Yeah.